All right, so we're going to start 7.5, increasing and decreasing intervals. So increasing means to get bigger, decreasing means to get smaller. So going into our key concept for today, an interval is a period of time between 2 points or times of time or events. So, for instance, a jogger begins her run around a park by increasing her speed until she reaches her normal jogging speed. She then jogs at a constant speed for most of her run, and finally she begins her cool down by jogging at a slower rate until she stops. So, this is the kind of thing that we're talking about, increasing and decreasing intervals. We don't have specific times. We're just going to kind of look at sketches and determine based off the graph. So when I look at this graph, I can easily see where she's increasing. So that's this part where another word for this would be warming up, right? Her warm up, where she increases to her normal speed until she reaches her normal jogging speed, in which that is where she is going to run. So that's going to be constant. She's going to be at that speed for a certain length of time. And then, which is where it means a constant speed for most of her run. And then finally she begins her cool down by jogging at a slower rate until she stops. And so this would be that cool down period, whereas this was our warm up period. And so the graph shows the relationship between the jogger's speed and time, and in increasing, so here we increased, then we are constant intervals and decreasing intervals. So really, as we go through, we're just going to be saying where are we increasing, where are we decreasing, are there constants? That's our point for today. So example 1, label each interval as increasing, constant, or decreasing. So I'm just going to come off to the side here. We're going to go for A, B, C, and D. So I'm going to look at where A is pointing to. So we're going from 20. Our line, if we think of it as slope, like from chapter 5, our slope is negative. Therefore, A's interval is decreasing because we are going down. So A is decreasing. When I look at B from this slot of time here, we're constant. We're not increasing, we're not decreasing, we're just staying the same at 0. Our speed is 0. And then at the end of that, when we get to C, we've got a pretty sharp increase. Our slope is now positive, so that will be an increasing interval. And at D, we've gone back to, we went from 0, we increased to 40, I'm going to guess miles per hour, and now we're just staying at 40 miles per hour for our drive. And so that would be, I'm guessing drive, we're talking AM speed, I'm going to guess that we're doing some type of drive in the morning. So D is a constant, and so maybe I wouldn't say highway if we're going 40 miles per hour, but we're on the road moving at a constant rate. So that's our first example. Can we say when we're increasing, when we're constant, and when we're decreasing? So example 2, label the graph to indicate which intervals are increasing, decreasing, or constant. We're just going to label right on the graph since it doesn't give us an A or a B. So on this side, and we always read from left to right. So I know I didn't say that in the last one, but we read from left to right, just like you read books. So I'm not thinking of the fact that from 0 this is going down. I'm thinking that from here, from our negative x values, as we approach 0, we're increasing. So this would be an increasing interval here, whereas from 0, as our x values go positive, we decrease. So then this one would be a decreasing interval. And so we can do this with any graphs. This is one of our function x squared, or they could look like the following, which is very similar to our beginning. Again, we're going to label the graph to indicate which intervals are increasing, decreasing, or constant. So again, starting from the left, I'm looking at this first interval here. This would be a constant because we're not changing our direction. We're not increasing or decreasing. It's just a zero slope. If it's a zero slope, that's a constant. Once we get to the end of that constant interval, then we start to increase. And then we get up here, we could call that 1, we could call it 10, but we get up here and again we have a zero slope, and so this would be a constant. And so one thing, so if we have, relating it back to slope, increasing would be a positive slope, decreasing is a negative slope, and constant is a zero slope. So those are ways that we can relate it back to something we already know. All right, example 3, the graph shows the speed of a commuter boat as it makes an evening trip. So it's asking us to compare constants. So part A, how many constant intervals are defined in the graph? So I'm just going to look for how many zero slopes do we have. And so we have one up here. We have one down here. It may be hard to see, but there is a line there. We have a giant one up here, and then another one here around 7 o'clock, and between 7 and 8. And then we just end. So when I look at that, that is 5 constant intervals. So we have 5. Now B wants to know how the constant intervals are alike. And so they're alike because they indicate a length of time. Sorry, I tried to do something very similar to the book so that it would be very similar to what your homework will look like. So they indicate a length of time when the speed is the same. So in other words, constant. Now, how are the constant intervals different? Well, there it is. 2 have the same number of minutes. Sorry, I lost track of where I was. In length and the same speed which is at 0 miles per hour. So we're talking about these two intervals down here. They only cover for one box, which would be the same length of time. And they're both going at 0 miles per hour. The other constants, so our other 3, the ones up here, so the other constants, or constant intervals, well, other constants, happen at different lengths and speeds. So not all the speeds were happening are constant speeds are the same, and not all of the length of time are we running at that speed. So those are just different lengths. I should put of time there. Sorry if that makes that hard for you. Lengths of time and speeds. So those are ways that you would see that written in your homework, because it's going to be one of those matching four options, multiple choice type of things. But yeah, 7.5, we're just determining, do we have an increasing interval, which means we have a positive slope on the graph? Do we have a decreasing, which we would see by a negative slope on the graph? Do we have a constant interval of which we know we'd have if we have a zero slope. And so that's all that 7.5 is.